Hi, my name is Dane Robinson, and this is my video on enzyme mode of action. What is an enzyme? An enzyme is typically a protein that acts as a catalyst, speeding up chemical reactions. You can usually recognize the name of an enzyme when it has the suffix "ase." For an example, we'll use lactase, the enzyme responsible for digesting lactose. Without lactase, lactose goes undigested, leading to some problems later on. However, when our enzyme lactase, shown in red, is present, our substrate, lactose, shown in purple and green, will bind to the active site on the enzyme. When binded, the breaking down of lactose will be sped up, thus leaving us with our product of glucose and galactose, shown as purple and green respectively. When an enzyme is present, the overall energy change of the reaction remains the same as if no catalyst were present, as shown by the red lines. However, what does change is the activation energy of the reaction. By lowering this threshold, it allows the reaction to happen easier and faster. How do enzymes lower activation energy? Different enzymes all have their own way of lowering activation energy, such as acid-base catalysis, where enzymes will donate or receive protons with their substrate. Covalent catalysis. This works by the enzyme covalently bonding to the substrate, which provides an easier, lower energy path for the reaction to take place. Metal ion catalysis. The metal ions stabilize charged intermediates and orients the substrate with the enzyme. Binding energy from non-covalent bonds, like hydrogen bonding and more, between enzyme and substrate allow for easier orientation, stabilization of intermediates, and bond making and breaking. Transition state stabilization. The enzyme binds to the transition state more tightly than the reactants or products. This lowers the energy of the transition state, which lowers the activation energy. The two widely accepted enzymatic specificity models are the lock and key model and the induced fit model. The lock and key model suggests the active site is fixed and rigid and perfectly complements the substrate, like how a lock only unlocks by a certain shape of key, whereas the induced fit model suggests the active site is flexible and conforms around the substrate when bound, like how a baseball glove will wrap around a baseball to fit perfectly. There are four types of substrate specificity. Absolute specificity acts on only one substrate. Group specificity acts on a group of similar substrates. Bond specificity acts on a certain type of bond. And stereospecificity acts on only one stereoisomer of a substrate. Think of enzymes this way. Enzymes are like this paper shredder and metal grinder. The enzyme, the paper shredder, speeds up the process of breaking down the enzyme, ripping up paper, but it won't shred metal as that's not what it's for. That's a job for the other enzyme, the metal grinder. To sum it all up, enzymes lower the activation energy of a reaction, thus speeding it up. Different enzymes have different ways of lowering the activation energy, and enzymes are very picky with which substrates they will bind to. Thanks for watching. Bye bye.